大家好，我是清华大学电机系黄眼介。那这一章我要介绍这个电流与电压的讯号在传输线里头传播的一些现象。那电磁学呢是有关电磁波相关的分析跟知识。在这一章我们先不介绍向量场。电磁波里头有电场有磁场，但是呢，当你考虑它的方向的时候呢，经常会有复杂的空间观念要这个拉进来，比较不容易理解。所以呢，我们先了解传输线里头电流跟电压讯号以波动的方式传输的一些现象跟概念，从这里来了解电磁波。那所以呢，我们会刚开始就先介绍一点基本的概念，然后呢，再开始做一些分析，也就是用一般我们电路的概念来做一些分析，然后呢，用几个特征例子呢来加强你的印象。但是呢，波在传播的时候就会有往前传、有往后反射的现象。那所以呢，第4个小节会有这个穿透跟反射的介绍。最后我们会有个单元的回顾。So in the first session, I'm going to introduce you a few basic concepts about a transmission line. So on these slides, I just want to show you a few photos taken from the National Synchrotron Radiation Research Center. From those 2 photos, you can see that a big microwave oven connected to a few pipes, and the high power microwave is transmitted through those pipes to particle accelerators. Inside the particle accelerator, the high electric field of those microwaves will be used to accelerate the electrons to high speed, near speed of light. And then those electrons will be producing the radiation for users. And sometimes it's not so difficult to see some coaxial cable in your house or in your lab. A coaxial cable consists of a core, conducting core, and then an insulator. Outside the insulator, there's another conducting layer. Between these 2 conducting materials, an electromagnetic wave can propagate inside. So this coaxial cable is also a quite popular waveguide or transmission line for transmitting electric signal. So in general, for transmission line, there's a generator producing signal propagating into a transmission line. And this transmission line is going to be responsible for transmitting the electric signal over some distance. And finally, the whole energy is delivered to your application. For instance, in this case, I put an antenna here. And on the last page, I told you that the microwave is transmitted by those rectangular waveguide as transmission line to particle accelerators and provide energy to do particle acceleration. So the signal on transmission line is mostly modeled as voltage and current. And fortunately, voltage and current are not vector field. So when we talk about the voltage and current propagating as a wave inside a transmission line, the concept and also analysis can be easier. And the variables in this system is the position and time, because the voltage and current are going to change over distance and time because they are wave propagating inside the transmission line like this. And a wave will have a wavelength and a propagation direction. So a transmission line is usually larger than the dimension of wavelength. Therefore, wave interference is going to be quite important in the analysis of transmission line because the phase of the signal at different location, at different point on the line is going to play a key role in the physics for energy propagation inside the line. So let's just examine the whole system of the transmission line, including the generator and transmission line, and also the application. When the wave is propagated to some boundary, quite often that you have reflection and transmission. If you don't have good impedance matching, which we'll discuss later, then you'll have reflection of the signal at a junction of the boundary between two transmission lines or between two materials. And once you have the reflection of the wave in the backward direction, it's going to superimpose with the forward propagating wave to form a standing wave like this. So you can see that from this standing wave pattern, the pattern will repeat every half wavelength. So in the transmission line, there's a characteristic length, which is the half wavelength. So the characteristics of a transmission line repeats every half wavelength. And we're going to see this when we analyze the transmission line later on. 所以呢，在这个基本观念的介绍上头我特别提到，就是一个传输线的话呢，它是用来把一个电磁波或者电磁的讯号，也就波动的讯号呢，从一端传输到另外一端。那它的这个大小，也就是这个电线的传输线的大小呢，通常是波长的好几倍，所以里头的这个讯号的相位还有干涉呢是很重要的。一般的电路里头我们不考虑到这些干涉跟相位的问题，因为通常这个讯号的这个波长呢远大于这个circuit 这个电路的大小，但是传输线的话就不一样，所以呢有所谓的 impedance matching， 还有这些 standing wave 等等的这个问题在里头，我们必须详细的研读。那在传输线里头呢，主要的这个讯号是电压跟电流。那这也为什么我们先拿这个传输线来讨论因为这个电压跟电流呢，它不是一个向量场，相对的会比较容易来建立一些波动的概念。那所以呢，一般的传输线里头呢，包含了3个部分，一个呢就是 generator 讯号源，然后呢再来就是这个传输线的这个传输的部分，最后呢是你一个 load 一个这个这个应用端就是一个这个负载在那个地方。那在传输线的分析里头呢，因为会有往前走的波，也会有通常会有往后走的波，形成驻波的这个情形。那这个驻波呢，它的这个 field pattern 呢是有一个周期，就是2/2波长的这个周期。所以呢，往后我们在分析传输线的各项的特征的时候呢，这个2/2波长的周期呢会经常的出现。那这个是第一个小节基本概念的部分呢，让各位先有一个基本的了解。